Okay, so here's our integral from a to b. So a is the lower limit and b is the upper limit for our integral. So what that's basically saying is, looking at this graph from a to b, you analyze the area from the lower limit to the upper limit. And f of x with respect to x and f of t with respect to t, it's the same thing. The definite integral is just a number. And since it's just a number, it doesn't matter what our variable is. We can change the x to a t and it won't change the value of the integral. Okay, so now we're going to go into some of the properties of integrals. So here's the first one, the integral from a to b of k dx. So this is basically, k is a constant. So if k is our y and k is always that constant, then the integral from a to b of k dx is going to be k times b minus a. And this can be seen with this picture here, as it's just a simple rectangle. B minus a is your x value, and then k is always your y value. Here are two examples of special properties of integrals. We have the integral from a to b of f of x dx equals the negative integral from b to a of f of x dx. And then we have the integral from a to a of f of x dx equals 0. Here's another property of integrals. So we have the integral from a to b of f of x plus g of x dx equals the integral from a to b of f of x dx plus the integral from a to b of g of x dx. And here's an example of that property. So the integral from 0 to 3 of x plus x squared dx is equal to the integral from 0 to 3 of x dx plus the integral from 0 to 3 of x squared dx. So this is a powerful property as it allows us to split up integrals in order to analyze them much more easily. Here are some more properties of integrals. So the integral from a to b of k times f of x dx, you can pull that k out, and then you have k times the integral from a to b of f of x dx. And then another property is the integral from a to b of f of x minus g of x dx is equal to, you can split this up just like we did with the plus. You can split this up into the integral from a to b of f of x dx minus the integral from a to b of g of x dx. So if we look at this, the integral from a to c of f of x dx plus the integral from c to b of f of x dx equals the integral from a to b of f of x dx. And this can be seen if you look at the graph for the case where c is between a and b. It's very easy to see from a to c plus from c to b is equal to from a to b. Very easy to see. So if we know that the integral from 0 to 10 of f of x dx is 12, and the integral from 3 to 10 of f of x dx is 8, find the integral from 0 to 3 of f of x dx. So how are we going to find this? Well, as you learned before, from a to c and c to b is a to b. So we can use that sort of thinking to know 0 to 10 is 12, 3 to 10 is 8. So we're trying to find here. So all we need to do is do 12 minus 8, or 4. So if f of x is greater than or equal to g of x for when a is less than or equal to x and x is less than or equal to b, or basically from a to b, then the integral from a to b of f of x dx is greater than or equal to the integral from a to b of g of x dx. And this can be seen with the graph here. You know that g of x is always less than f of x, so you know that the area under it has to be less than or equal to the area under f. Okay, so we're going to find this area using geometry. So the integral from 0 to 6 of x minus 2 dx. So we're able to recognize that x minus 2 is a straight line, and this is the graph of that. So what we're going to do, we notice that it turns into two triangles. So we're going to find the area of each of these triangles. So the area of triangle number 1 right there is 1/2. Our base, when is y0. If we look there, y is 0 when x is 2. So we go from 0 to 2 here. So our base is 2. And our height, we started at x equals 0, which means that y was -2. That goes to -2. Now don't forget that negative. That's a very common mistake that people forget. It's below the x-axis, so the value is negative. Now the area of triangle number 2 is 1/2 base times height again. Our base this time is from 2 to 6, which is 4. So 1/2 times 4 times height. What is our y here at 6? Our y is 4. 1/2 times 4 is 8. Then we simply add the two triangles together for an area of 6. Okay, so here's another area using geometry problem. So we're going to look at the integral from -3 to 3 of the square root of 9 minus x squared dx. So if we're able to recognize that this is the formula for a semicircle, then this problem becomes really easy. So what you do, you see this as the semicircle, you draw the semicircle out, and we're able to analyze the area of a circle is pi r squared, so the area of a semicircle is pi over 2r squared. In this case, our r is the square root of 9, which is 3. So we're going to do 3 squared, which equals 9 pi over 2. Here's an example problem. So we're going to want to express this limit as a definite integral. So how are we going to do that? Well, what we're going to need to do is recall our definition of a definite integral formula. So what that was is the definite integral equals the limit as n goes to infinity of the summation of x sub I delta x. So now, when we've got these lined up, it's very easy to see now how it matches up. And what we have here is this is our f of x, and we're multiplying by our delta x. So, and this is our interval. So if we can see now, we can rewrite this as the integral from 0 to 2 pi of, and our f of x, that's right here, this is our f of xi, which is this portion. So we have sine squared x over x plus 2 dx. Here are two of the most common mistakes that I see. The first is forgetting that the area under the x-axis is negative. People do this, it messes up their values. Don't let that be you. The second common mistake is notation. Good notation is where you go and you include the dx at the end of the integral, and you keep the integral sign throughout the problem. Bad notation is where you leave out the dx and you drop the integral sign throughout the problem. That's going to mess up your values. You're going to lose points, lose track of what you're trying to solve in the problem, and that's just poor notation altogether, so don't do that. Most of the time the questions on here will be no calculator questions, but sometimes if there's a calculator question that you need to use the calculator to find the integral for, what you're going to do for the TI Nspire Cast, you're going to click Shift plus, and then you're going to type in your lower limit, your upper limit, whatever your function is, and then whatever respect to whatever variable. Click enter, and that's it.